Once the magnetic field collapsed, Mars's death was not instant. It was slow, methodical, relentless. The solar wind, that stream of charged particles hitting the planet at 400 kilometers per second, began to interact directly with the upper atmosphere. Without the magnetic field to deflect it, the solar wind tore into the ionosphere, ionizing gas molecules and giving them enough energy to escape Mars's gravity entirely. Atom by atom, molecule by molecule, the atmosphere began to leak into space. And at 4 billion years ago, the Sun was also more active than it is today. Solar flares and coronal mass ejections, enormous eruptions of plasma, were more frequent and more violent. Each one delivered a concentrated burst of stripping energy directly to the unprotected Martian atmosphere. Scientists using NASA's MAVEN spacecraft have actually measured this process happening today. Even now, even with Mars's thin modern atmosphere. MAVEN found that during a single large solar storm, the solar wind strips away the modern Martian atmosphere at roughly 100 grams per second. That sounds small, but multiply it across millions of years. Multiply it by a young sun that was throwing off far more intense events, and you begin to understand the scale of what Mars lost. It took roughly 500 million years for the atmosphere to thin to a critical threshold. As it did, the greenhouse effect weakened, temperatures dropped, the liquid water on the surface began to freeze. And as it froze, something paradoxical happened. The carbon dioxide that was keeping the planet warm began to be absorbed into the ice and rock. The greenhouse effect weakened further. The planet cooled faster. More ice formed. The cycle accelerated. Scientists call this a runaway glaciation feedback loop. Once it starts, nothing stops it.